All right. Hello, everyone. Welcome to our latest webinar on identifying and discovering hidden patterns and demand forecasting in the retail industry. My name is Chris Johnson. I'm the US-based sales director here at Veraqor. For those of you not familiar with us, as a brief overview, Veraqor is a global technology provider of cloud migration, information technology, and digital business transformation services. Veraqor serves various industries, including healthcare, manufacturing, retail, energy, oil and gas, and technology. We work with each of our clients on reimagining their business models and developing strategies to help grow their business in new ways. So on the call with us today is our data scientist, Khurram. Khurram has over 20 years of experience working with various high dependability and complex industries, including government, utilities, manufacturing, healthcare, telco, transportation, and defense. So quite the background. He has developed a highly scalable, distributed, and optimized solutions with advanced algorithms and made them function seamlessly. He has spearheaded many cross-functional projects, which led development, infrastructure, and quality assurance teams for both on-prem and cloud-based solutions. So Khurram is going to discuss with us today how technology and digitalization can be used to leverage predictive analytics to optimize labor and logistics operations and create new growth opportunities for your organization. He will also provide us insights into the latest trends and best practices in demand forecasting. So without further ado, Khurram, the floor is yours.
Thank you, Chris. It's nice to see you again. Hi, guys. Thank you for attending this webinar. Today's topic, as Chris has mentioned, we will be trying to identify those hidden patterns within our data sets, and that will help us create a forecasting models for demands in the whole supply chain, whether it's a retail, manufacturing, or oil industry, oil and gas industry, or pharmaceutical, whichever. And at the end, we will be discussing how Microsoft Azure AI stack, we can utilize them and make them available for our quick adoption, and how this stack is going to transform our services. And so let's talk about today's agenda. I'll be focusing, I have divided today's talk into multiple important topics, and I'll build it over step by step. First thing first would be, we'll discuss how we have to understand the data is no more just a data. It has become at an enterprise level, it has become a strategic asset. We'll have to understand what exactly are the patterns, and not just simple patterns. There are certain influencers within those patterns, and we have to identify them. We'll have to dig, and we'll have to see how the digitalization and automation of the supply chain is important, relevant to the industry. What are the best practices, and how this can leverage the whole industry into making a lot of best cases in terms of how they can save in terms of financially, how they can make their operations more optimized, how they can create an environment which is more operationally more secure for their human resources, so on and so forth. At the last point, we'll be discussing what are those cloud available AI backed stack that we want to propose and adopt, so that our technology transformation, adaptation, and results are consolidated at one place. And we'll be also seeing how, and the Chris will also be able to explain how the Veraqor basically can make certain offers in this matter. So first thing first, the supply chain is interconnected availability or supplies of hardware, services, it could be operations and technology, and they are offered in such a coordinated way that one task is dependent on the completion of another task, and it's such an interconnected chain that unless one task is completed, you cannot have a next stage of a task completion. There are many intermediary involved. So for example, if you want to move an item from place A to place C, There has to be for example, a trucking company. There has to be a company which supports services of house moving or office moving stuff to be loaded to. Then there are maybe cleaning services, or there might be different service providers which get involved from while you're moving from state A to state C. Similarly, the data in the whole supply chain, it demands a complete visibility in the whole business operation. Uh, that's the term that is most commonly used is 360-degree omni-channel view. What do we mean by that is, once a data is generated from whichever point it is, and throughout its journey, it should be available to an organization how it is generated, whom within a system it has affected, who has been viewing it, who has been consuming it for different reporting purposes or analytics purposes, and so on and so forth. So for a data to be available at all different stages for all different stakeholders in a different states, and having different characteristics during all those phases, it should be available for all viewership. And in that perspective, data and cloud, they are inseparable. The technology it adopts to has an year-on-year growth rate at 29%. So if you want to have your data, whether you are geographically located to dispersed locations, whether you are within the same country or location, but you have multiple satellite offices, your data moves between different departments. It has to have a strategy where it could be stored, produced, consumed, be available to different users. So the cloud technology, which is being available for last almost a decade now, has been very quickly adopted by a growing number of organizations. The overall industry, the supply chain industry, that has been targeted and been projected to grow to 15 trillion US dollars by the end of this decade. So what we are seeing is a quite bit of a challenging in terms of number of operations, in terms of uh, new use cases that might come in the business processes. So that's one area that where technology and specifically data has a huge potential. Um, I call data not just as an information anymore, it has become a strategic asset for an organization. What do we mean by a strategic asset? It means with an access to data, whether it is authorized or unauthorized, it becomes such an important tool in your key strategic uh, decision making. Why? Because with the help of data massaging, with the help of data mining, you can get some really deep insights, and those insights might help you uh, take certain actions which will help you optimize your operations. Number one, it could also help you grow in terms of better planning at your, let's say, cash flows, or be at more control in terms of how your enterprise plans when to invest in certain new plant or globally. So in those terms, once you have a deep insight, you are able to make some very strategic decisions, and those strategic decisions have some really long lasting implications. So you need to have a right control and right mechanism in place so that they are not readily available to those who are not intended for this data. So you have to have a right kind of a data strategy and framework in place. One of those good frameworks and industry best practices are DMBOK, adopted by DMBOK. They have been also adopted and performed by Department of Defense, NIST. So yeah, once you have these roles and responsibilities and associations well defined within your organizations, you have a better viewership and access to your relevant data. And of course, when we have to see making our cyber physical system more resilient and responsive, and as I was saying before, if you treat a data as a strategic asset, it will be able to show you a total 360-degree view of omni-channel, um, who came in, who tried to access what type of a data, what type of authority it has to, at what level of playing it can perform, what type of transactions, authorization, access, governance policies, and all those. So once you have a very resilient and responsive and a very strategic framework in place in your organization, the whole data becomes a strategic asset of your organization to help grow in terms of its global impact. We we have been discussing about the data, and of course, the next stage within this within this is the digitization and automation. Digitization means you have everything digitized in terms of their operations. So, for example, you have ERP system at your local manufacturing sections. You have container shippers, you have logistics, you have warehouses, and all those systems are integrated and they are automated in such a way that one effect or one decision or one click basically impacts the next step, and you have the complete visibility of it. Is a digitization and what I call as an intelligent automation of your supply chain. So how it helps, it gives you a better control over your overall supply chain. It has a tendency for forward planning. You can plan what type of items do you want to store for your warehouse, in how much quantity do you want to store, how long do you want to store, or whether you want to procure something, you want to make certain planning of next 6 months, how you can do that and start creating some kind of a cash flow for that. So your ability to connect and relate with that data to your planning, uh, and that thing gets done by using analytics, and that's getting done from your once your supply chain processes have been already digitized and automated. It helps you uh, improve collaboration across the board. So, for example, your warehouse has certain or number of warehouses have certain SKUs in place which haven't been disposed of for so quite some time. So, rather than acquiring new raw material to produce some new SKUs, you can utilize them, and all this collaboration basically happens once your warehouses, your operations, logistics, and procurement department are interconnected, and then they can see your whole operations under one uh, dashboards or under one roof. That helps them in terms of improving their cash flow for future planning and managing your available stocks. Uh, and since every action, whether it's performed at logistics, at a warehouse, at a store outlet or whatnot, once that item, which might be critical for a certain class of a customer, once it is readily available to them, they are happy, and the churn rate will be high of that customer coming back to you again.
Hey, Khurram, actually, just interject. We have a question, if you don't mind answering. I think it's kind of related to that last slide. So we've got, so these are very interesting. However, I'm from the oil and gas industry. Is this good for my segment as well? If you could maybe provide some insight there outside of maybe the retail industry, I guess is where this is going.
Yeah, and the uh, once we start doing the identifying the hidden patterns, they are absolutely correlated with all the industries, whether they are oil and gas, whether they are manufacturing, whether they are automotives, uh, whether they are pharmaceuticals, because supply chain is uh, directly related with an ability of an organization to plan ahead and have enough assets at their disposal to make certain key and strategic decisions. So yes, to your question, they definitely this whole idea of trend analysis and demand forecasting is applicable to every industry. Just that the use cases, specific use cases, would have a different approach to be implemented and um, different methodologies to be adopted. But the overall framework, um, the overall framework remains the same. So I hope I have answered your questions.
That's great. Thank you.
So this is just a quick snapshot of how your digital supply chain can help different businesses in different segments. If you have a very proper distributed um, data strategic specific um, a policy or a framework implemented. So if you have logistics, whether you are into a manufacturing or whether you are into any segment of the um, industry, what it does is basically there are three different um, factors which are very common in every industry. Number one is how speedily it can be adopted, transformed, and it can start producing the results. In terms of how flexible it is to be adopted into your specific industry, and in terms of how good it is at in terms of cost reductions. So in every section, um, if I go from the bottom to top, you have some kind of a transportation cost, which are flexible enough. Then you have sourcing and flexibility in terms of supply chain resilience. That's where you reduces your cost. So you have three different variables which are basically going to control how your overall digital business is going to save a lot of money. It will show the flexibility to adopt within your organization, or if you try to improve and make your operations more flexible, how it can be adopted, and what is the complexity level that you might or your organization might have to go through in terms of how speedily it could be adopted across an organization. So the two factors, factor number that I was discussing was integrated, and the number two was automated. So once you have all your components in a supply chain integrated, it could be order fulfillment, it could be storage and transportation, it could be material management, it could be demand, it could be inventory management, it could be anything. The circle of integrated supply chain and the modern digital version, the Industry 4.0 standards that adopt and integrate and associate all those points and helps them automate so that you have a 360-degree of visibility of, for example, if something at your control room, they are able to see what exactly is happening at, let's say, transportation point, where exactly it is, how exactly it is moving, whether it is in the packaging stage, whether it's the distribution stage, or wherever it is. So integrated and automated transformation are the current new best practices. The industry 5.0, which is it has moved on to now. Unfortunately, it is beyond our scope, but I just wanted to give you a flavor of it. It's called a digital twin. So you don't necessarily have to perform each and everything physically. You can create a digital a twin of your process, business process or operational cycles, whatever they may be. And then you can actually simulate those cycles and see the results um, by yourself so that you can analyze if certain cycles or certain operations are going to save you uh, X amount of money or not. So let me give you a quick example of it. So for example, if you want to um, see if I want to place a new uh, power plant or a production plant to uh, another city, how much cost it would be. So you have all your external variables, you have in financial variables and environmental variables and all those, and then you feed them in your digital twin module, and you have your own supply chain constraints. So you just feed the all available data. You have feed them all the influencers, and then you see if within the supply chain it is going to be a beneficial without well before actually making an investment. So that's industry where the industry 5.0 is moving. Maybe in sometimes in near future we'll have a dedicated talk on that, but I just wanted to give you a feeling where exactly the next stage of industry is moving ahead. Okay. Yeah, now we'll be discussing about some uh, actual patterns within data, which are um, crucial in a sense that why if so anything you do, and whether it's a business process, a human action, set of actions we perform, there is always a pattern. And anything that does not follow that pattern has some kind of um, a red flag raising out of it. So as we discussed in the beginning, the idea of the talk is to identify those hidden patterns within the data, and then we will try to associate those patterns with how they are going to affect our demand forecasting, and eventually how we are going to use those technology stacks. So first thing first, I'll introduce you a few hidden patterns within the data, which will help you identify your unique use cases. And once you're able to identify, because one shoe doesn't fit all, and all these different patterns are, some of them are for long term, some of them are for short term. Maybe you don't have a lot of data, uh, and you have just for small amount of data. For example, you don't have a data for 1 year or 2 years or 3 years, but only for, let's say, 3 to 6 months. Which different type of a method we can adopt. Or if you have a very long-term data, but your specific requirement is to, which is bound on the time, which method to adopt to. Or there are a number of different identifications and you want to associate to them and then create a model out of it. So we'll go through and I'll also associate show how to use those different patterns in our artificial intelligence and machine learning techniques so that those different one method or multiple methods will produce different desired results. Excuse me. So periodic patterns, these patterns are when they are repeating themselves after certain lapse of time. So I'm taking a time series analysis method, which means uh, at least for me, data is available for at least for 1 year, and I want to see how certain task, certain demand, certain action has been performed over that 1 year, and what has been the pattern. So, for example, if I say I'm located at it's a, let's say, I mean, in a geographically located area where you have a hot season for the 10 months of the year, somewhere around the tropical, and you want to see how the sale of lemonade affects throughout this 10 months of period and what has not been during the last any those 2 months. So you have a larger scale, and every day you have set number of sale and once you start distributing it over this 12 months, and then these 12 months are further distributed over daily sales or a weekly sales. Excuse me. So you will be able to identify there are certain patterns at certain amount of or at a certain interval of a day, your number of lemonade being sold are higher than, let's say, another interval of the day. So for example, during the afternoon or noon hours, they are sold more, and the rest of the time, the number of sold lemonades are less. So periodic patterns spread over a period of time. There are no internal and external influencers. Why? Because we have identified it located on a near tropical region. It's a 10 months consistent sun, high temperatures. So no external variables that's going to influence on the sales. So you will get a very non-insider, non-outsider variables, or in pure statistical terms, there shall be no outliers. Now, I may have in a second types, I may have an associative patterns. Um, it's more or less like it's occurring in terms of groups, and they are associative to each other. So, for example, if one item of a, okay, so I have the same example again, spread it out. But I have also seen a pattern that if my lemonade sales increases, so does the sale of, let's say, ice lolly increases. Or if my um, ice lolly increases, so does the number of sales of my lemonade increases. So they have an associative property. So one item, if their number of sales increases, the associative item that is part of that particular item also increases. So they are kind of influencers to each other, but the baseline remains the same. There are no external influencers, but both these two items are influencers to each other. One goes up, the second goes up too. And then we have now abnormal patterns. This is the most obvious and most uh, serious and most simpler ones. They occur absolutely out of nowhere. There is no behavior to which they conform to. They I'm really sorry, guys. And they have a clear they have a clear deviation from I'm sorry. So the abnormal patterns, they are absolutely clear deviation from the normal behavior, because uh, they would just simply unexpectedly appear, and they have no set patterns, either because the external behavior, either because there are too many external influencers in the whole data set, and they have been not identified, and they have been basically causing a lot of outliers. And these outliers are basically influencing their behavior. I'm sorry. Structural patterns.
It's that time of the year here, I will say, but allergy season is here.
Yeah. Yeah. Uh, yeah, perfectly, Chris. It's you can say even when I'm behaving like this and I'm coughing, it's absolutely abnormal behavior because this time of the year, usually we don't have a sudden change of weather and people don't get sick very easily. And this time of year, they are getting just like me, and out of nowhere, they're just coughing around. So that's one live perfect example of abnormal patterns. So in the next two, they are on the surface, they look pretty organized, but within them, they have a very or vice versa as well. On the surface, they would look very chaotic, but within their structure or how the data is laid out, they have a very defined patterns of how they are uh, how they basically hide between those patterns. So one is a structural pattern and the other one is a chaotic pattern. So within a structure, you have, let's say, set of graphs or you have a set of clusters. And what I may so I have a specific requirement, and that is I want to identify those suburbs where uh, the rental income or the rental price of an apartment, two-bed apartment or three-bed apartment, is relatively very low. So it might, on the surface, it might look, if you're in a certain suburb, the price might be on a higher end, but you will be surprised that within those suburbs, the prices are actually lower on the lower end. So there are some structural ways, or there are some rules because of which, or whether they are old, they are they're not so expensive. And in terms of chaotic patterns,
Hey, Khurram, if you want to, just take a brief, a few minutes to kind of recoup. I mean, it's definitely no worries. I'm sure that people want you to make sure that you can flow through, and if you need to maybe stand up or drink some water or anything,
yeah, let's
feel free.
just take a 30 let's just take a 1 minute break, and hopefully I'll be back.
Yeah, go take. Yeah, and while everybody waits, you can actually check out on our website at veraqor.io. If you go to the supply and chain management section of our website, we've got some great information there that nicely kind of recaps everything here. So yeah, I mean, certainly too, I think as we progress forward, from if you have any like further questions, if you want to see like a demo of this, I mean, we definitely would be more than happy to walk through that with you. So we definitely have some more questions here too. So we'll wait near the end here if we have the opportunity to get them answered. But yeah, man, the floor is yours whenever, if you're feeling better, and I can sit here and try and piece through it, but you're the expert here, sir. So
Now hopefully I'll get it through this time.
you're good, man.
Yeah. So Uh, Structural patterns are basically we discussed already. Mhm. So what we are discussing right now is a graph analytics. That's just one last quick thing about these different hidden patterns. They are okay. Just one last quick thing about these hidden patterns were they are mostly based on mathematical and statistical techniques. So they are more uh, inclined towards having certain data sets which might not be inclusive of those factors which are humans. So when I say that, it means there are certain behaviors which human basically, um, whenever he is doing some kind of a transaction, he exhibits, and those behaviors are basically counted in the overall system design. But these are, since these are the statistical ones, so whatever uh, is observed is recorded and placed in the data set. So I'll explain to you when we will discuss the graph analytics, what I mean by that. The graph analytics is a modern technique where you create a graph, and I'll show you the first what I mean by that. Okay, that's more of interactive. So if you see on my left side, this green box, it could be anyone, someone who's entering the store. The store could be, for example, a sports shop. Uh, and the four blue balls that you see, the nodes that I call them, these are the characteristics, properties this specific person has. So, for example, he's a tall man, he's into sports, he wants to buy something. So he has a certain persona around him, and those persona has a different characteristics, and he is exhibiting those properties around him. So once inside the store, he interact with different items. For example, if I see here, this might be Nike's joggers. These might be some, sorry.
Hey, Khurram, I think we have someone with their hand up. Martin, I don't know if you have a question, feel free to you can write it to us in the Q&A. Thank you.
Yeah, please. Okay, so this might be a Nike's joggers, this might be some, some hardware stuff, or it could be anything, list of anything that he interacts with. Maybe he wants to purchase them, just checking their qualities, blah, blah, blah. And each of these items creates an association with this person. Now you have another person who's also in the store and who's also interacting with the same set of devices. And he is also creating a relationship with these items. Uh, and these two people who may be in the real world might be totally uh, unknown to each other, but still they are making some kind of a relationship. What kind of relationship? Both are into sports. They both are, for example, in the store to make certain purchases. They have some common interests, so on and so forth. So all these characteristics, all these properties, associations in the state in which they are in a particular location, blah, 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 these are creating a whole set of graph. That
And
graph.
actually, we have a quick question too. Sorry not to interrupt. Figured it was relevant to what you're talking about here. But Martin, he's asking what are the AI modules available to handle obsolescence, especially in spares as machine and are changing fast in modern electronics. I don't know if you can see this on your end as well.
Yeah, look. I'm not sure if I got the question. Can you, some kind of a repeat?
Yeah, it says what are the AI modules available to handle obsolescence, especially in spares as machine are changing fast in modern electronics?
So there could be a different, for example, if you want to, let's say, let me have give me a second to read over the questions. Yeah, you can use Kurt Melham's method. That's one way you can pretty adopt methods which are fast-moving items for those which have a high degree of either high degree of failure, or it might have a higher degree of success, but that's on the negative side if it is on a failure. So yeah, you can use a Kutman-Helms method, but you might need to fine-tune it for again for the internal influencers as well. Okay, so we were creating the graphs. Once we have these two gentlemen interconnected based on certain properties, we have a small subset of a graph. Of course, there might be so many people who are interacting with different items within that shop. So they will all create associations, not only with the items they are interested in, but also how they interact with each other, with the different items in the shop, and so on and so forth. So we'll have a very huge and complex graphs between different personas, and those personas will help us create a extremely dense, large, and complex graph model. And we have to use those graph models to analyze and identify our anomalies, because if you are using statistical models, then you have to do a lot of statistical techniques. And if you are using graph analytics, then you will have to use anomaly detection in order to identify if the set of cycles that you want to perform on those are actually following through. So there are certain type of graph analytics. One is pathfinding. It's one of the shortest paths between the two, which means is if you are able to directly associate the two nodes in the graph, that's easiest for you, and which basically shows you that these two nodes are directly related, and all their associations, both on the right and the left side, are directly interdependent, in the sense that once the association is upgraded at left side, the degree of upgradation will affect the on the right side as well. Centrality measure is about noting down the importance of nodes in a graph. So what I mean by that is, if a node has some level of hierarchy, so if a node is, let's say, is a manager, and the subnode number of employees, if if a sub node gets upgraded or he's promoted to manager, how his rank is going to affect the rest of the association within that graph, that will be impacted and uh, identified too within that graph values, so that next time when whoever is trying to access that graph knows the new values of that particular association of those nodes. I'll show you an example of community detection that's very useful when we are trying to identify a particular anomaly, or if we are trying to identify the hidden patterns in the data. So let's first go to the identifying that case. That's just one, I was just going to show this. This is how a banking unit would basically first associate itself with a account holder, will have a different transaction records associated with how much the credit card is being used, when it's being um, some amount has been transaction, what are the loans he has, what are his address, blah blah blah. So all the flow that is related to that particular account holder, the bank would hold with it. That's one use case. The second use case would be, yeah, this is one graph. So imagine this one big graph, and I'm trying to identify a anomaly. The anomaly would be if I somehow remove this community level subgraph, or if I try to inject it. So, which means I have already in my whole system, it could be here, or it could be in this system. I have every business organization has identified certain business processes and certain rules, whether you want to introduce a new approval or a rejection. So that particular node has to be first approved in order to be associated somewhere with this node. If it is not being there, or it's not being identifiable, if it is trying to associate itself with that particular node, it means it has not followed that process, and it's kind of an anomaly. So every anomaly, whether if I talk in terms of network security protocols, every network security association or a department has certain protocols of authenticity, when, how, where those particular authorizations are going to follow for that particular node to be associated with. So you have your whole IT department, you bring in your laptop, you can't access their whole IT ecosystem immediately, because until unless your device is recognized within their whole ecosystem through their, let's say, MAC address, until that MAC address is registered, within your network, you cannot access any of the services, whether you're using Office 365 degrees or anything. So there is always certain protocols to follow before you can have access to the corporate IT system. So exactly in our graph analytics, until and unless you have gone through that life cycle, you are an anomaly within that network, and that anomaly, either it exists or is trying to insert itself, shall be a case of fraudulent activity. Chris, do we have a question or something? No.
Yeah, you've got two here. So it says, I see there's too much reliance on statistical techniques rather than more easily consumable methods, such as observations or surveys. Why so?
Yeah, I mean, observations, that's a good question. I mean, you can have a lot of observations, but those are not going to be easily convertible into some kind of an actionable insights. You always need some hard numbers to come up with some hard numbers to take certain decisions. And thankfully, that comes only through some statistical methods. And those statistical methods eventually give you some deep insights. Surveys are, since they are more human uh, influence, they can have a higher degree of bias. And there is no, even if you want to check what is the degree of biasness and want to remove that, still you need statistical methods. So yeah, we need, nevertheless, we do need statistical methods to come up with the very straight questions and very straight answers.
Okay. And then the other question was, there are many techniques that's been discussed with different phases. How do I know which one to use and when? Is there like a one fit fill all answer?
No, you can't have one technique, which solves all your problems. So, I mean, there we saw in the demand forecasting, there are different techniques. Sorry, the hidden patterns, there were different techniques, and they were for different use cases, even for different industries. So in every case, you'll have to use some homegrown techniques, some statistical models, combine them, throw them in a machine learning engine, or use some graph analytics, especially for the first level if you have some first degree or second degree information already available. You take it for advantage. You create your own machine learning techniques, or use them whichever are available. Refine those processes, and then once you have a higher, your degree of confidence start growing on them, you basically further train them, and start producing results which have higher degree of acceptability and low bias.
Got it. Okay, thanks. Oh yeah, and just I guess we're approaching up here like 4 minutes or so. So not to rush you, just wanting to kind of share
Okay.
where we're at.
Yeah.
It's good
I'll
stuff.
Yeah, I'll make sure not to go into too details, and I do apologize for the my conditions. So we'll sort it out somehow. So again, we had different hidden patterns, techniques, and similarly, based on those patterns, we have demand forecasting techniques. So, but all these techniques that we have mentioned here, which you will have an access to, are basically reference in a direct reference to having those statistical techniques, being able to identify those hidden influencers, those hidden outliers. And once those outliers have been outcasted, and you have a high degree of confidence on your results, these techniques are then applied so that they can give you a better degree of uh, how to predict future trends. For example, one of the most famous techniques that I'm just trying to cover here is ARIMA. It's autoregressive integrated moving average. So what you do is it's a game based on time series data. And whether you have a large set of data or whether you have a small set of data, you have already identified and isolated those um, influencers, those outcasters, and then you spread it out, and you do it over set intervals of time frames, or whatever the parameters that you have set. So it could be a location, it could be a time, it could be certain quality metrics, blah, blah, blah. And then you spread it out, and then you start throwing your relevant data on those time frames. So one condition could be your stock exchange. So you want to see between 2008 to 2020 during different intervals and different uh, scenarios, what has caused the crashes of the stock exchange. So you have different parameters. For example, it could be your high inflation, it could be your um, the insurance or subprime. So you have to spread it out in a time series manner, introduce your those E parameters based on which you just want to um, extrapolate. And once you have all those parameters and conditions fulfilled, then you'll have a certain set of trajectory, which will show you at what point of time crash happened. So ARIMA is pretty good at identifying against those different intervals using different parameters. Another one is basically multiple aggregation prediction algorithm. So what you do is it's a little more refined than ARIMA. You have all your aggregations sorted out at an ingestion level. You throw in your forecasting techniques. There might be one, there might be multiple. And then you do your computational tasks within a layer of machine learning. And then the combination which the machine learning model does, and it starts producing you the results which are based on the specific criteria that either you set up in the machine model techniques or whether you had set up in the forecasting techniques that where the aggregation of the forecast were to be combined at. So this is a bit more faster and a quicker way of doing the ARIMA. Bottom-up forecast is mostly a very simple technique, which is more or less like a to identify a demand during a promotion, what type of a how the product would react to during certain time of a year, or again how it's going to impact the company revenue. And the last series that I just wanted to touch very quickly, since we are almost out of time. I'll be using or very heavily we were suggesting that we use cloud-based technologies for our consolidated artificial intelligence and machine learning based techniques. There are a couple of technical reference architectures that I have referred to them here. Of course, these are just a quick flow of, I would say, if data flow, a functional flow, or a operational flow models. But of course, these are all how we have to transform our supply chain in a completely cloud environment, which is completely integrated and automated. And with that, I come to my end of this webinar.
All right, perfect. Well, thank you so much. I know that you got I don't know if the allergies, everything's all acting up, but definitely take care of yourself. This is very informative for us. I really appreciate it. And guys, we're going to have this, we recorded the session, so we'll certainly be sharing a link, and we appreciate your participation and joining us today. And if you have any other questions, please let us know. Certainly we can provide a lot more insight. So we're definitely looking forward to talking with you here soon. So appreciate your time today, and we'll talk with you soon.
Thank you, guys.
Take care.